A geometric sequence or series is one in which a successive term is found by multiplying the previous one by some common ratio, which in the general case we call r. I will run through the general case, where we call the first term a, alongside this specific example. To find the nth term of a geometric sequence, we must start with a and multiply it by the common ratio a certain number of times. This number is given by n minus 1. To find the sum of a geometric series after n terms is a bit more complicated, but most of the time the formula is all you really need. I will derive it here by first writing the sum and factoring out the first term. If you recall the binomial expansion, you might be able to see that the expansion of 1 minus r to the power of negative 1, which is the same as 1 over 1 minus r, is given by 1 plus r squared plus r cubed, and so on up to infinity. This looks similar, but we can only say this sum is actually equal to 1 over 1 minus r when we have an infinite sum, in other words when n is infinite, and we must be in the domain of the binomial expansion, which requires the modulus of r to be less than 1. This is not very general, but it may tempt us to factorize out a 1 over 1 minus r from the bracket and expect that whatever remains is just equal to 1 when n is infinite and the modulus of r is less than 1. Factorizing out a 1 over 1 minus r means multiplying each term in the bracket by 1 minus r, resulting in this pattern. Notice that after the initial 1, each negative term is cancelled out by the successive positive term, all the way until the final negative term, which is given by r to the power of n. Thus, after the cancellation, the sum is equal to a over 1 minus r multiplied by 1 minus r to the n. This term here does indeed go to just 1, as we predicted, when the modulus of r is less than 1 and n is infinite. And so under this condition, the infinite sum of a geometric series with first term a and ratio r can be just written as a over 1 minus r.